You ever stop and think about what's really going on under the hood of your favorite app? Well, today we're going to pull back that curtain. We're going to look at the invisible architecture that powers pretty much our entire digital world and uncover the core ideas that make software fast, efficient, and, reliable. Yeah, it's a feeling we all know, right? You tap an icon and you're either in instantly or you're stuck in that digital waiting room, just watching that spinning wheel of doom. The difference between that instant gratification and a super frustrating delay, it's not magic. So what is the secret? It really all boils down to method, not magic. The secret is buried in two fundamental ideas. First, how you organize your information, and second, the strategy you use to actually process it. All right, so let's tackle that first part head on. Organizing the chaos. I mean, how do we bring any kind of order to the insane amounts of data our programs have to juggle every single second? And that's where something called a data structure comes in. You can just think of it as a specialized container for information. It's designed from the ground up to make storing, finding, and even changing that data as efficient as possible. So why is this such a big deal? Well, first off, efficiency. The right structure means your app runs faster without gobbling up all your device's memory. And then there's the whole right tool for the job thing. Think about it. A contact list needs a super fast search, but a text editor needs efficient typing and deleting. Totally different jobs, so they need different structures. And on a much bigger scale, these structures are the absolute foundation for, well, everything, from massive databases to the operating system running on your phone right now. A really great way to think about this is a toolbox. Sure, you could just dump all your tools into one big, messy bucket. Good luck finding that one screwdriver, right? Or you could have a perfectly organized toolbox set up for a specific project. That toolbox, that's your data structure. It makes finding and using exactly what you need incredibly fast and efficient. Okay, so if data structures are the toolboxes, what are the instructions for actually using the tools inside? That brings us to our second key component, the recipe. And that recipe? It's called an algorithm. It's really just a simple, step-by-step set of instructions designed to solve a very specific problem, whether that's sorting your music playlist or finding the fastest route home on a map app. Let's make this super real for a second. Imagine you've got a list of numbers and you need to find the biggest one. The algorithm is actually pretty simple. First, you just assume the very first number is the largest one. Okay? Then you look at the next number. Is it bigger? If it is, boom, it becomes your new champion. And you just keep doing that, repeating that process until you've checked every single number on the list. That simple logical process, that is an algorithm. And this right here is why algorithms are so critical. Look, a bad recipe might work just fine if you're cooking dinner for 2 people, but it could be an absolute disaster for a banquet of 1,000, right? It's the same idea. A poorly designed algorithm might work okay with 10 pieces of data, but it could grind your entire app to a halt when you throw 1,000,000 at it. The efficiency of the algorithm is what determines whether your software can actually handle real-world scale. But here's the real key. Neither of these concepts, data structures or algorithms, works in a vacuum. Nope, they exist in what you could call a perfect partnership. It's a combination of structure and strategy. You really can't separate them. The way you structure your data, your toolbox, that directly determines which algorithms or which instructions you can even use in the first place. And then on the flip side, the algorithm you want to run will either be lightning fast or painfully slow, depending entirely on the data structure it's working with. They're like two sides of the very same coin. Okay, so with all this complexity, how do programmers manage everything without just getting totally lost in the weeds? Well, they use this really powerful idea called abstraction, basically focusing on the what, not the how. This brings us to something called the abstract data type, or ADT for short. It's kind of like a blueprint. It describes what a data structure should be able to do. So, for example, a list should let you add items and remove items, but it says absolutely nothing about how it actually gets that job done. And that is the core idea right there. By separating the what from the how, we can separate the concept of a data container from all its nitty-gritty implementation details. So why is that so incredibly powerful? Let's stick with that list example. The list ADT just gives you a promise. You can add things and you can remove things. Simple. But under the hood, a developer could build it using a simple array, or maybe a more complex linked list. As someone using that list in your code, You don't need to know, and you really don't care about those internal details. You can just focus on solving your bigger problem. That is the power of abstraction. All right, so we've covered structures, we've covered algorithms, and we've covered abstraction. But let's bring it all back home. Why does any of this actually matter in the real world? It matters because these aren't just, academic theories you learn in a classroom. They are the invisible engine running literally everything you do digitally. When you search for a contact on your phone, when you sort your emails, when you get recommendations on a streaming service, you are watching these principles in action. They are the absolute bedrock of all modern software. So I'll leave you with this thought. The next time an app feels incredibly fast and just responsive, take a second. Appreciate the elegant data structures and the efficient algorithms that are working in perfect harmony just beneath the surface. What invisible architecture is making your digital life possible?